MTD CNC, bringing you the latest engineering news via video media.
Hello and welcome to MTD TV. My guest at this time is Paul Enser from ITC. What's new from WIDIA, Paul?
Really, it's the evolution of the VariMill program, Joe. A while ago we spoke about the VariMill, anti-harmonic flute geometry of a 4-flute end mill, and this has now been improved and extended in the range to long series with necking for deep pocket activity and long wall finishing, offering true performance over long reaches. WIDIA have brought out a small VariMill catalogue with increased ranges, taking us into the VariMill 2, more multi-fluted variants, long reaches, more flutes, and really aiming more at the tricoidal market.
So yeah, tricoidal milling, everyone's doing it at the moment. It's very en vogue, isn't it? And these are the players, aren't they, WIDIA?
Yeah, they've taken the anti-harmonic geometry from the standard VariMill. Going into the VariMill 2, they've introduced high helix angle tools and more flutes on the tools. And then they've actually combined that with a tricoidal milling catalogue, which sort of takes the black art out of the tricoidal milling process.
And why has there been a big growth in this area, do you think? Why is everyone starting to apply tricoidal milling strategy?
The art of tricoidal milling is basically to control the chip thickness. You control the chip thickness, you control the stresses imparted onto the workplace material, the stresses on the machine, controlling the heat at the cutting surface as well. There's several playing fields in the tricoidal milling whereby the helix angle and the number of flutes will increase or decrease the performance of the tool. So increasing the helix angle, increasing the number of flutes means you can basically machine quicker. If you're machining quicker, your metal removal rates go up. The tricoidal method of circular interpolation means that you can also take far deeper cuts with far more accuracy, with less load on the spindle of the machine, and so you can do large cuts on more lightweight and lower spindle speed machines.
The interesting thing I find with tricoidal milling, if you watch it, the cutting tool looks like it's working a lot harder than traditional methods, but tool life actually increases using this strategy, isn't it?
Yeah, you're spreading the wear over a greater area of the cutting tool for a start off, and obviously if you're using more of the flute, you're spreading the load over more of the flute as well. But you don't get the shock of going in and out of cut. If you have a conventional slotting routine, you have one side of the slot which is a rough surface finish where it's conventionally milled, and the other side of the slot is climb milled with a better surface finish. With tricoidal milling, because you're interpolating around the slot, you get a good surface finish on both sides, but the tool is actually used far greater, so you don't get the stress on the flute.
And obviously, as I say, it's a big growing area. Not enough people apply this technology still, but it is growing. Is this down to the CAM companies, do you think?
Yeah, the CAM companies are coming forward and offering the tricoidal milling methods. What WIDIA have done with the range of tools is combine that with a catalogue which explains about the methods, explains how the tools work and how to get the best from the tools. So many tooling companies nowadays proclaim that they have tools for tricoidal milling, but won't offer technical data for the use of the tools. In the tricoidal milling catalogue, it gives you data for both conventionally milling with these tools, which is possible, and also if you want to use them in the tricoidal method, it gives you the actual speeds and feeds data, the sizes of cuts, and the step overs that you require for doing tricoidal milling programs.
So if we were to take this tool as an example, could we engage that whole flute length?
In theory, yes. Obviously, it would be a selective application, but in theory you would be able to use the whole depth. Obviously the depth across your AP, your step over, is relative. So the deeper you go, the less step over you have, but you are still controlling the chip method.
And what sort of radial engagement can we expect?
Well, typically people talk about tricoidal milling at about 4% step over, based on 2 times diameter flute length. But recently Hanita have been working on new tools that go into the WIDIA range, which allow you to go 15 and 20% step over. We've recently done some trials with Mill CNC where they've been applying the VariMill 2 and they've used a 15% step over, going at 10,000 RPM at 6 metres feed rate in a mild D2 steel. So real high performance stock removal rates.
Yeah, it's impressive. Why would we go, I see the advantage of a 5 flute, the extra feed rate, but when would we use a 4 flute for trochoidal milling and not the 5 flute?
If you're going to go to trochoidal milling, ideally you would use more flutes. The more flutes, the faster the feed. But this is all born from the original 4 flute anti-harmonic tool and going right through the range now and offering it up, really offering choice. If you wanted to go a conventional slotting application, the 4 flute would be better for the swarf evacuation through the flutes. If you wanted to go to a true trochoidal milling application, this 5 flute variants and even going through to 7 and 8 flute variants now. They've even pushed the boundaries with a ripper geometry, which still offers the anti-harmonic flute geometry as well. So you've actually got the chip breaker facility on that tool when you're doing trochoidal milling to actually break up the needles of swarf as well.
Yeah, so what's the advantage? Obviously we're going to have shorter swarf. Does that mean we can increase the radial depth of cut?
Yeah, that tool is designed for greater metal removal rates. The radial depth of cut will increase, and as the chips get larger, on a longer fluted tool, you'll get a long, thin needle of swarf. Obviously, the sinusoidal form of the ripper will actually break that up into nice small chips, which if you've got an air blast typically on the machine when you're doing trochoidal milling, will actually evacuate those very quickly.
And we've got a 7 flute here. Presumably the feed rate's quicker, but the radial engagement's reduced.
Correct, yes. Typically when you have more flutes, obviously the feed rates go up, but your AP or your step over would decrease slightly by compensation. It's really picking the application, but if you've got the choice of 4, 5, 6, 7 fluted tools in various diameters, various lengths, you can pick a tool that's ideally suited for the particular application that you're trying to run.
And would that application be materials driven? So the 7 flute, would that be for harder materials or softer materials?
Yeah, good question. Once again, on the range of tools that they're producing, there's standard geometries and there is actually dedicated geometries for steels, stainless steels, can be used going into cast irons, etc. And we're doing a lot of titanium geometry tooling now as well. So it's really pushing into the boundaries of the aerospace, nickel-based super alloys as well, which are now coming into play with trochoidal methods.
Yeah, it's a big range, and more importantly, you've got the support from ITC here in the UK.
Correct, yes.
Great, thanks Paul.
Thank you, Joe.